Importance of software interrupts. System call interrupts. They provide a controlled mechanism for programs to interact with the operating system. Exception handling, allowing the operating system to manage unexpected conditions gracefully, improving the robustness of programs. Efficiency. Efficiency enable efficient execution of tasks by allowing programs to request services without polling or busy risk. Real world examples. File operations. A program uses a software interrupt to request the operating system to read, write, or close a file. Process management. A program requests the creation or termination of processes using software interrupts. Error handling. An illegal operation like dividing by zero triggers the software interrupt to handle the exception and prevent program from crashing. Maskable interrupts. Maskable interrupts are the hardware interrupts that can be ignored or masked by setting a specific bit in the CPU's interrupt flag register. Examples: peripheral devices like printers, keyboards, and network interfaces. Non-maskable interrupts. Non-maskable interrupts hardware interrupts that cannot be disabled or ignored by the CPU. They are reserved for high priority events that require immediate attention. Examples: critical errors, memory parity errors, power supply issues, and watchdog timer expirations often generate NMIs. Exceptions. Exceptions are special conditions or events that disrupt the normal flow of a program's execution. They're a crucial part of the error handling in both hardware and software contents. Types of exception. Hardware exceptions, software exceptions. Real world examples: file operation. When a program tries to read or write file that does not or is it not accessible, it can raise an exception. Network communication. Handling interrupts in an operating system step by step. First step is interrupt generation. Interrupts can be generated by hardware devices and software programs. Interrupt signals. When an interrupt occurs, the hardware sends the signal to the CPU. The signal can either be maskable or non-maskable, as we discussed. And maskable and non-maskable only can be in the hardware for only hardware interrupts. Interrupt vector table. The CPU uses an interrupt vector table to determine the appropriate response to an interrupt. IVT is a table of pointers to interrupt service routines, each corresponding to a specific interrupt. Interrupt mechanism. Saving saving context. Current execution state. The CPU saves the current state of executing the program, including the program counter registers, onto the stack. This is necessary to resume the program after active encounter. Disabling further interrupts. Disabling further interrupts to prevent another interrupt from occurring while the current one is being handled. The CPU is temporarily disabled further interrupts. Fetching the ISR, executing the ISR, and then restoring the context. Re-enabling interrupts, resuming normal operations. These are the steps involved in interrupt handling mechanism. Resuming normal operations. Resume execution. The CPU resumes executing the interrupted program from where it left off. Types of interrupts and their handling. Hardware interrupts typically have higher priority, are handled immediately. Software is often by OS3 systems calls and may have lower priority compared to interrupts. Exceptions and traps. These are triggered by specific errors or conditions that need immediate attention. Importance and applications of importance of interrupts efficiency. utilization, real-time responsiveness, hard-time interaction, error handling, multitasking, and concurrency. Applications of interrupts, input and output operations. To run smoothly, the keyboard and mouse operations, the disk operations, and the network informations. Real-time systems. Interrupts are essential in real-time operating system for handling time-sensitive tasks such as in automotive systems, medical devices, and avionics, where timely responses are critical. Embedded system. Many embedded systems rely on interrupts to manage sensors, actuators, and other peripherals, ensuring responsive control and data acquisition. Timers and clocks. Systems timers generate periodic interrupts to maintain the system clock, schedule tasks, and manage time sharing among processes. This is all about interrupts. Thank you.